Welcome to another study session Tuesday on cyber insecurity. Thanks for joining us for the fourth episode of our Intro to Python series. I saw that there's some new people in chat, so let me introduce myself. My name is Brent Eskridge. I was a software developer for 6 years, a computer science professor for 17 years, and now a threat intelligence analyst. I've programmed everything from shell scripts to a network server to simulations that run on supercomputers. So I have lots of experience making all kinds of different programming mistakes, and I enjoy helping people learn not to make those same ones and to make completely new ones. So if you want to connect with me, you can find my socials there in chat using !Brent, B-R-E-N-T. If you connect with me in Discord, I just request that you send me a message telling me what you hope to get out of this series. So first, I want to thank my moderators for being here. We have a zero tolerance policy on toxicity in the cyber insecurity channel. We want this to be a positive learning environment for everyone, and moderators are here to make sure that that happens. If you're put on a timeout or a ban, talk to the moderators about it in our Discord. Not me. I'm not even supposed to be looking at chat, so the mods get upset about that. But moderators are not here to stifle chat. They're here to ensure that you get an opportunity to ask your question and learn. I welcome questions throughout the study session, so I find that I usually get too few questions, so feel free to ask questions. But we have a few rules. First, ask your questions once and only once. The moderators do see your questions and will send them to me. So I'll try and answer them as quickly as I can, but I may not answer them in the order they come in, and I may delay it depending on the content and where the flow is and things like that. Second, there are some questions I just can't answer on stream, such as like my Python program isn't working, or Python isn't installed right, or something like that. For obvious reasons, I can't discuss that here in live stream. So we do have the Discord. You can ask the questions in the Intro to Python room while we're on stream here, and there are some people in there that will help answer your questions. You can also do it after the stream is already aired. So I have it set up so I get notified every time there's a message in there, and so I'm happy to help, and there's other people in the community that are happy to help. You can find that just !Discord. As a quick reminder, so this series is based on content from my Intro to Computer Science course when I was a professor. It's the same content, just without the tests and the homework and the crippling debt. So there's no prerequisite knowledge needed for this series. We will be using some basic math examples. I think I broke some people's brains last week with some of the math. We've got very little math tonight. It's all some angle stuff because we're going to be drawing some pretty pictures. And I think after this is the last chapter where we're going to be talking about any math. So if you're math phobic, you can rest easy. We're going to focus on easy to define problems so that we can focus on the problem solving process and then implementing that in code. There's a GitHub repository with all the content. You can find it with !Intro to Python there in chat. All the content is free. I've got notes, resources, exercises. There's a link to the book we're using called Think Python. You can download it for free as a PDF or buy it from your favorite bookstore. I've no affiliation with the author. I've just used his book for a long time, and I think it's great. So as a reminder, every week we start off with an algorithm of the week. So let me start that here real quick. So I post this on Twitter, usually on Monday, so you have some time to work on it. If you'd like to drop your solution into Discord chat, I'm happy to take a look at it and may even talk about it here on stream. So this week we actually have two, and there's a slight difference between them. The first one is find a name in an unordered list of names. And so the unordered is important here. The second algorithm was find a name in an ordered list of names. So the idea here being that this one is ordered. And so I want you to think about what the difference is between the two algorithms. So let's start with the ordered list. And so if you remember, there's a few things that we want to talk about with every algorithm. The first one is a problem. Now, this is, stating the problem, and it may seem obvious, but in my experience, a lot of people new to programming, even experienced programmers, jump right into code without making sure they fully understand the problem. So the idea here is, can we fully state the problem? Now, the algorithms I'm choosing are pretty simple, and so I can pretty much go with, the problem statement as I have it here, because I've created the problem statement, so they're pretty simple. So we've got that one. Then we have preconditions and postconditions. So preconditions are what needs to hold true before I start the algorithm, and then postconditions are what are the result of the algorithm executing. So think of this as like a contract. The preconditions are the things that, the person asking me to solve the problem or giving me the information needs to give me to solve the problem. And then postconditions are what I'm going to do to fulfill that contract. So the preconditions in this one would be, we have an unordered list of n names. All right, so we could say we are provided a list of n names. Now, we talked about this last week. This n, we know it's not going to be negative, right? I can't have a list of -3 names. That doesn't make sense. But the question is, do we allow 0, right? So in computer science, we generally allow lists to be of 0 length. So for example, if I have a list of things to shop for, when I go to the store, once I get everything, I've marked it off my list, I still have a shopping list. It's just empty. So last week, for simplicity, we said it had to be 1 or larger. This week, let's make it a little bit more difficult and say we're going to allow 0. So this n is going to be greater than or equal to 0. All right. So we allow a list of n names. All right. And so when we find a name in there, so how do we then indicate that we found it? Well, there's a couple of things that we could do. One, we could just say, yes, I found it, which may be helpful if that's all I want to know, if it's just in there. But I may also want to find out exactly where it is in the list, see if I could pull it out. So let's say for this particular algorithm that we return the index of the name in the list. Okay. Now, we haven't talked about this yet, but when we get to lists later on, you will find that computer scientists are weird and we start counting at 0. So for Americans, this is very weird. But when I've traveled to Europe, this is normal, right? So when I stay in a hotel, the ground floor is the 0th floor. So we just start counting at 0 in computer science. So the index, if it's the first name on the list, it could be 0. And so we need to find out something here. What do we do if the name's not in the list, right? So it could be that the name's not in there. So what we'll say is return the index of the name in the list if it is in the list. Otherwise, we return -1. So -1 is like this special value we're going to use that basically means it's not in there. All right. So we can work with that. And so this helps us to fully define the problem so we can then look at the algorithm. All right. So let's start working on the algorithm here. So we're going to start off with the assumption that we haven't found the name. All right. So we basically are going to define the location of the name as -1. All right. And the reason we do this is because we haven't found it yet. So as we get further on in the series here, we'll talk about, do we set the initial default to success or failure, right? And it really depends on how the problem is set up. Here, we're initializing and setting it up for failure. And then when we find it, we're going to say we're successful. Other situations, other problems, we may want to say, we're going to initialize and set it up that we're going to be successful, and then we're searching for a special case that causes us to fail, right? So in this case, we're going to default to failure. So then the next thing we need to do, and I'm going to use a term here that we're going to talk about later this evening. And what I want to do is I'm going to start with the first name and iterate through all the names in the list. So iterate basically means one right after another. So we're going to start with the first one. All right. Now, there's one thing that I skipped over on our preconditions. We're not just given a list of n names. We're also provided with a name to find. So we've got to have those two things. So as we go through, I'm going to start here and say, does the current name match the name we were initially provided? So the provided name. If it does, success, we found it. Okay. And so we can then store the location of the current name in this as the saved location. The challenge here is we've kind of gotten ahead of ourselves, haven't we? Because we're not keeping track of where we are in the list. So what we need to do here is I need to restart this and say something along the lines of the index of the current name is 0, right? So we found it, and at this point we can say store the index of the current name in location. So we'll just call it location. And then I can just quit, right? I'm done, I've found the name. Now, it could be the name is in there multiple times. We could have said, I want to find the last occurrence, and so I need to go through all of them. But we never really said that. So we're just going to quit whenever we find the first one, right? Now, we can also say, no, it doesn't match, right? And if that's the case, then we're going to move on to the next name, which we'll do right here, but we need to update the index of the current name by 1. All right, so after we check the first one at 0, then we check the second one at 1, the third one at 2, and so on. So that way we've got an updated one, and I can go back and say, go on to the next name, right? What we'll find is actually Python will allow us to be less verbose in this. We don't have to go through and be as verbose in this as we're going through in Python. All right, so here it is for an unordered list. So I'm going to copy this, the preconditions and everything, to the ordered list. And so the question is, how does this problem change when it's an ordered list? Well, let's go through. Are the preconditions the same? Yes, we've got a name and we've got a list of names, but this is ordered. I'm going to put it in capitalize it here because it's important. The post conditions, we're still going to do it. Now, and I hesitate to use the word trick, but you know, it's a trick. Because it's ordered, we actually can do something here, right? So if it's ordered and we have the name Alice, Bob, Charlie, right? And I'm looking for, let's say my name, Brent, right? Or actually, let's do a different one. Let's say Alex, right? Once we see Alice, we know that Alice comes after Alex, so we can quit looking, right? We don't have to look through the rest of the list because this is ordered. And so while this same algorithm will work, it will still find it. We have an opportunity to tune it a little bit. So we can say, instead of just saying, does it match? We could also say something here. We could throw one in right here, move this to C and say, is the current name after, mathematical terms, it'd be greater than the provided name, right? And if it does, then we can say the name we're looking for isn't in the list, right? Because we've passed where it should be. right? If I'm looking for Alex and we find Alice because the I comes after the E, we know that, hey, wait a minute. If we were to find Alex in the list, we would have already found it. We've gone too far. And so what we can say is, so is it in there? Yes. That means we have passed where the name should be. It isn't in the list. And we can quit. All right. So again, the original algorithm would have worked, but we have an opportunity to optimize it. And this gets back to, do you understand your problem and exactly what you're trying to solve? Now, in the long run, is this going to make that big of a difference? Not really, right? If it's I was kind of say this, if it's a list of 1 million names, you might see it, but computers are kind of fast, right? Now, if it's a list of, 100 million names, well, now we're talking that you could save some time, right? And we'll talk about this as it gets later. This sort of understanding the efficiency of a program is important. But at this point, I'd much rather you worry about getting the correct program and having it work properly. But as you start getting more experience, start thinking about these ways to optimize it. Don't worry about it too early, but there's things to think about. There's a couple of questions that we've got. The first one was, the problem of the week was to sort a list of numbers from lowest to highest from a manual. That was last week's. So if you'd like to look and see what the solution for that was, you can go look at the video for last week's episode. So I talked about that. And again, if you want to talk more about it, I'm happy to chat about it in Discord. All right. So with that, let's start looking at some code. I do have a question there from Echo1. How long should I expect to learn Python if I learn and practice 2 hours a day? So, I'm going to give a snarky answer here, but it's really truthful. It depends on what you mean by learn. If you're asking how to be an expert, I have been programming either as a full-time position or as a professor or whatever for over 25 years. And I am still learning and still finding new ways to screw up and things like that. So I would say you never really master it. How long until you become proficient? It really depends. So it depends on what sort of problems you're wanting to solve with programming. So I've worked with computational biologists, basically people who are using programs to analyze the collective movements of animals. So anything from fish to drone footage of zebras and things like that. The amount of Python they needed to know is very different than some of the people I work with that run, connect Python up to programs that are running on, Amazon Web Services. So it really depends on the sort of problems you want to solve. And I know that's not a good answer. People like very definitive answers, and I usually frustrated my students because I always gave it depends answers. So it really depends on what you're doing. You could probably get fairly competent if you're pretty consistent, a couple hours a day in a month or two. It really depends on what sort of problems you're wanting to solve, how much background you have, right? So have you ever programmed before? If you've never done any programming before, it'll take longer, right? If you've done programming before, then it's just learning a new language, right? Every new programming language you learn, it works out to be a little bit easier than the last one. So it really kind of depends on your background and what your goals are. So the nice thing is this stuff, it's easy to spend some time on, walk away. There's a lot of resources of this series is one. There's lots of free books. There's lots of opportunities to learn, and you can dive in and focus on the type of problems you're interested in. So again, if you would like to chat more about it, I'm happy to do it. And I'm sorry that I can't give a good answer, but it really kind of depends on the person and the background and the problems you're trying to solve. All right. So now I think I'm all caught up on questions. So let's dive into chapter 4 today. So there's a couple of these chapters in the book, and it seems, a little out of place. So this one, we're going to be doing something called turtle graphics. The idea of these chapters, so it's this one and I believe chapter 9, they're really kind of stealth chapters. They're there to introduce another topic, but it sneaks it in there. So we're going to talk about iteration in this one and interface design and some things like that, but we're going to use the context of turtle graphics. So if you don't know, turtle graphics is a very simple drawing utility. The idea is, think that you've got a turtle that runs around the screen and has a pen. It can go in a direction, it can turn left and right, go forward, go backward, and it can pick the pen up and put the pen down. And that's basically it. But you can do some pretty interesting things with it. So if you want to look at some of the interesting things you can draw with this sort of stuff, L systems are really cool. I once told a student about it, and they came back the next day and found all sorts of cool things they could do. L systems are used like in video games to generate realistic looking trees and bushes and leaves and things like that. But it's pretty simple that you can do some stuff with. So we're not going to get there today, but if you want to take this and kind of go to the next level, L systems are pretty cool. So let's talk a little bit about how we're going to do this. So this is built into Java, but like math, we have to import it because it's not in by default. So we're just going to start off here and say import turtle. All right. And so what that'll do is this will import the turtle package so we can start drawing. Now, for those of you who've done some programming before, we're going to do a little bit of object-oriented programming, but I'm not going to dive into the details. So what we have to do is we have to create a turtle. And we have to give the turtle a name. And so historically, I have Bob the turtle. And this is how you create a turtle. So again, this kind of goes into something we haven't talked about. This part right here, it's object-oriented. Don't worry about it. Just know that this is how we create a turtle. And we can tell it's a turtle because if I do print Bob here and then run it, it says it's going to be a turtle object. And you can see here on the screen that I've got a little triangle here that is my turtle. And I haven't used it to draw anything yet. So Bob the turtle is just sitting there, not moving. So if you look in the Python documentation, it's got all the API for how to program on this, but we'll do some simple things here. So I can tell Bob to move forward. And so I can do Bob and FD because programmers are lazy and I really don't want to spell out forward. And so I'm just going to abbreviate it FD. So I can run it there and you can see he drove ahead 100 pixels, right? I can have him turn. So I can turn 90 degrees to the left. And so Bob LT for left turn and 90 degrees. And then let's say I want to move forward again. All right, so I want to do Bob FD 100. So I do this and you can see I went forward 100, turned left 90 degrees, and then move forward 100 again. All right, so now that's kind of cool, but let's do something a little bit more interesting. So I'm going to introduce something here. So if you've ever done programming before, you know about for loops. So I'm going to introduce repetition here. And so we've talked about being able to iterate through things. So we have a for loop. As we'll talk about in a later chapter, this is called a definite loop. Okay. You can also hear it referred to as iteration. So it's a definite loop because I know when I start out, I'm sure how many times I'm going to go through the loop. So for example, here, I'm going to do for I in range for, and I can say print hello. So when I run this, it does the drawing, and then I have hello. So I'm going to turn off Bob the turtle here for a moment. I'm going to just comment out this code so it's still in here so we can see what's going on. So what I've done is I have gone through here 4 times. So you can see I've got a 4 here and printed out Bob. So what it did, so this declares my loop, and then everything that's indented here is what's called the loop body. And this is what's executed every time we go in the loop. So let me show you something here real quick to give a little bit of an idea. So I'm going to print out I. And so it still brought up Bob. But you can see it printed out the numbers 0, 1, 2, and 3. Now, remember what I said earlier, computer scientists are weird. We start counting at 0. It has to do with how arrays are structured in memory and offsets and things like that, that I'm more than happy to geek out and talk to you about it on Discord. But for right now, know that this range returns something like a list. It's not exactly a list, but it returns a list of 4 numbers. In this case, it starts at 0. So the numbers are 0, 1, 2, and 3. So those are 4 numbers, but it doesn't get to the number 4. So basically it starts counting at 0. And so we actually get to this number minus 1. So if I wanted to actually get to the number 4, I'd have to go to actually 5 in this range. All right. And what it does is for each value it goes to, it shoves it into the variable I. So if you remember way back in the first episode of this series, I said, do not use single variable letter names like X, Y, and Z. Choose meaningful variable names that will help you in the long run. And I fully acknowledge that this variable goes against that. However, this is a special variable. It's not special to Python, it's special to programmers. So this is what's called a programming idiom. So I'll use this. Using I is a programming idiom. All right. So basically think like a convention. Whenever you have a loop, you use I. It's just what programmers do, right? Short for index. We'll talk about later that you can actually have loops inside of loops. And if you want to do that, the next letter is J, and then K. And then if you need L, you need to rework your program because it's you're nesting those too deep. But we'll talk about that later. But the idea is this is one of those that's an exception to the rule. Okay, so we can do it 4 times. So why don't we repeat this stuff that we've been doing with Bob and use a loop to have Bob draw a square. All right, so let's use a for loop to draw a square. All right, and feel free to ask questions whenever. I'm happy to take a little detour and answer some questions. So, all right, so I'm going to create Bob again. All right, and now I want to go through the loop. So I'm going to do for I in range 4. So I want to do this 4 times. So I'm going to have Bob move forward 100 pixels, and then Bob make a left turn at 90 degrees. All right, so I'm going to put some comments in here. So move forward. I usually write the comments first, but rushing today. And then a left turn. All right, so now let's run this. So we can see he drew a square. So I'm going to scroll up a little bit here if I can do it. So we can see the square here. So we created him. He moved forward, then turned left, moved forward, turned left, moved forward, turned left, moved forward, and then turned left again. All right. So we got him, got Bob the turtle to draw a square. And so we can say that's really cool. I like squares, but I'd like to do that more than once, right? Because at the moment, I've just got the code here. And so if you remember from previous weeks, so we spent 2 weeks on chapter 3 talking about how to write functions. So we could write a function that takes all of this code and does something called encapsulation to wrap all of this into a function so I can call it and I don't have to write this code all the time. So this is going to be something called encapsulation. So if you can think about it like the little tiny pills you take, right, the little capsules, and the capsules hold things in them, that's what this function is going to do. It's going to encapsulate it and put all the guts in here. All right, so Chris has a question. Why do I have a colon after the for I in range, but not after the next two lines? That's a great question. So if you remember back when we were working on functions, so let me see if I can open it back up here. When we defined functions, there was a function definition here that had a semicolon. And so what this did was this defined the function, and then we had the semicolon said, all right, that's my definition. Everything that's indented now is the body of the function. The same thing is going on here. So I have a for I in range. So basically the colon here tells Python, hey, I'm defining something and I'm going to indent it. This indented stuff is special, treated as a block, right? So other programming languages have the lines in and semicolons and things like that. Python doesn't do it. It uses the indentation. So the semicolon basically tells Python, all right, special stuff is coming up. Take all the things that are indented and treat it as, in this case, the body of the loop. And then once I jump out of the indentation, I'm done with the loop, all right? So that's what the colon means. The name turtle comes, so Emmanuel's got a question, where's the name turtle? It's turtle graphics. It's, back when computers were really slow and big and didn't have a lot of memory, the basic graphic stuff you could do was turtle graphics. And the idea was just simply that a turtle would walk around the screen and you could pick up a pen and put it down. So I don't know the history of that beyond that. It's one of those things that it's turtle graphics. It's been around for a long time. So at this point, it's used for educational purposes. People don't really use turtle graphics for things other than educational, and then finding some creative uses like L systems. Okay. All right. California has a good question. So where is range defined? Range is a special function that is defined in Python just like print. So you can see here in the syntax highlighting, we have it so this purple color, idle will choose the purple color for any functions that it knows of. In this case, print is a function, and so is range. So range is one of those built-in functions, and we can even go, and I've got the link, I think, in on the GitHub repository. I highly recommend that you create a bookmark for the Python documentation. So it's pretty good that it goes through and lists some things. So I can start it up here real quick and show you real quick. So you could see Python API and then range. So it's in the built-in functions. And so you can see here, let me increase the font size so everybody can see. And we've got range right here. And so it targets. So we're just giving it a stop, and it actually stops before that. But you can also give it a start. You can say a step. So I can do start at 3 and go to 40 by 3 or whatever. So there's some good documentation in here. So I highly recommend that you get a bookmark to save that. So hopefully that answers the question. But yeah, it's a built-in function. Okay. So we're trying to now take all of this and put it into a function. And so what we've done is we're encapsulating it. So the idea is we're taking all this code and wrapping it up in a function, bundling it in a function so we can call it again. So to go back like what we had before, I am going to create my function. And so it's just going to be something simple. I'm going to do the same sort of thing I did here. So for I in range 4, and then my turtle forward 100, and then my turtle left turn 90. And then I have to call it. So I'm going to comment this out so I don't draw 2 squares. And I can call it and say draw square with Bob the Turtle. And so let me pause here real quick and go through this. So remember, this variable only exists within this function. And what I call it has no bearing on what it's called outside the function, right? So this is just a label internally. notice that we've copied the same code over, but it's now indented twice because I have to indent it once because it's part of this function. And then this one would be indented a second time because it's a body. So this whole thing is the function body, and this is the body of this particular loop, right? So if I had more that I could do, so I could say like print done, if I wanted to say that I'm done, right? And so now I can do it. Oh, I missed N. Right? And so it still did the hellos, but it drew it and then said I was done. All right? And so we've got the same sort of thing here, but now I've encapsulated or wrapped it up into a function that allows me to call it whenever I want, right? So if I wanted to draw another one, I could. So I could say, I want to move Bob forward, let's call it 300, and then draw another square. So if I run this, it draws one and then draws the next one, right? And I could have, if I wanted to, do some things like pull the pen up, which means when he moves, he doesn't draw, and then put the pen down when I'm ready to draw again, and some things like that, right? So we can call this function multiple times, right? So we've used encapsulation, and this is a big computer science term, and my students, I wasn't big on definitions, but there are a few things that were pretty important. Encapsulation is one of them, because it works well with the next term I'm going to bring up, which is called abstraction. Abstraction is a big concept in computer science and programming in general. The idea is we're trying to get away from the details. You'll probably also hear it as generalization, right? So encapsulation and abstraction are two sides of the same coin. They're different concepts, but you can't have one without the other. So let me explain a little bit as we go through. So I like that I'm drawing a square here, but I don't like that it's always, the sides are always 100 pixels long. I'd like to be able to change that. And so what I can do is I can abstract away from the problem, and I can say, you know what? This algorithm is really independent of the fact that it's 100. I could pull that out and just say whatever the distance is. So I could say I want to draw a square of any size, and I give it my turtle, and then also the length, right? And so now I can even use the exact same code if I wanted to. It's just instead of passing 100 or calling 100, I just give a length. So now I could say, draw square any size, pass Bob, and then now say, you know what? I want the sides to be 200 long. And so when I run this, notice my square is now the length of the sides are twice as long because I pulled that value out. So in the language here, I abstracted away to a more general problem of drawing a square. This is drawing a square where the sides are 100 pixels long. This is drawing a square where the sides are any length. All right? So California has another question. Why is this one not indented? This one wasn't part of the function. These were part of functions or in the body of a for loop. You remember all the way up here, I didn't indent Bob because I was just executing the commands. Once I have these sort of things, we'll see them, a number of these programming structures, in this case, a for loop, I have to indent to say, this is special, this belongs with the loop. If you've done any programming before, sometimes you'll see it with curly braces. So C++, C, Java, they do this with curly braces. And the guy who invented Python said, you know, most people, when they write this, they indent the code anyway, so let's just do away with the curly braces and use indents. or indentation. So indentation basically signals that it is a part of a for loop, or in this case, the part of a function. And so that's what that indentation means. This isn't part of a function and this isn't part of a for loop. So that's why this code was not indented. All right, so hopefully that answers the question. So the idea is start looking at it. Indentation means it's a part of something, whether it's a part of a function or a part of this loop. And so what you'll see as we get to more complicated code is you'll see the code kind of go in and out as it's indented, basically grouping the code into different blocks. So this is the block and the body for the for loop. And then this whole thing is the body of the function, and so on. All right. So abstraction and encapsulation are two sides of the same coin. I can't use abstraction, right, where I pull away the details if I haven't encapsulated it and wrapped it in a function, right? If this were just code, I'd still have to have all the details in there and I'd have to rewrite it all at once. And I can't really have encapsulation where I wrap it up without having some sort of abstraction, right? Because draw a square, I've abstracted away from exactly how I'm drawing a square. At this point, this code right here doesn't care how it occurs, all that it occurs, right? For all this code cares, it could make right turns and draw a square. And so we really haven't defined that. It's just basically when I call it, it draws a square. All right. Emmanuel's got a question. Do I consider encapsulation important for code legibility? I think encapsulation is important for lots of things programming. So yes, it makes it legible, but for you to write programs of any size, you're going to have to start writing things in functions, which is encapsulation, right? And again, this gets into the theoretical, computer science professor part of me that likes to define these sorts of things. Most people use encapsulation without ever knowing the term and just saying, oh, I want to write a function. And that's fine. It's just I've found that when people, new programmers start learning the terms and learning why you do things, it makes programming a lot easier, and they're able to pay attention and catch on because they understand the why. And so that's why I'm trying to bring this up, right? So we have encapsulation, and we've generalized the length, but we also have another value in here that's pretty hard-coded, right? And that's the number of sides. I could abstract this away and draw a polygon of whatever size I want, right? I could draw a square is a polygon, so I could still draw a square, but maybe now I could draw like a hexagon or an octagon, right? So let's pull away. And so here's where we're going to do a little bit of math, but don't worry, I'm going to do it for you. And so I want to generalize even further and draw a n-sided polygon, right? So we've got a couple of things here. So I'm going to kind of define the problem and then we'll go with it. So I'm going to comment out drawing our square here. So I'm going to define a function called draw polygon, right? And I still have to provide it with a turtle. Now, I do need to specify how many sides it has, right? So before, we just assumed because it was a square. So I'm going to have to give it n, how many sides, and then I've got to do the side length. All right, so now we've got to think about this, and I want to write some comments out here. So these comments are going to be our algorithm, so we're going to think about it, right? So if we're going to do this, we're going to iterate, so I'm going to throw that term in here, over each of the sides. All right, so just like we did with the square. So then once we're in there, we need to move forward whatever distance we're going to do. And then I need to turn left by the correct angle. So before we were doing 90 degrees. That was because it was a square. So we've got to figure out what that correct angle is, right? And we also have to figure out how many of the sides. So we've got the sides here. So I'm going to start filling in a little bit of code here. So I've got for I in range n, right? Now, I'm going to pause here real quick. Remember, if n is 8, so it's an octagon, I'm going to get the numbers 0 through 7. So it doesn't matter that I end at 7 because I'm not really using this value I for anything. I'm just trying to do things a number of times. If I actually cared about this value, we'd have to worry about what the value is. All I cared about is I'm doing it 8 times, which I'm good with. All right. So I'm going to then move my turtle forward side length. All right. Then I have to figure out what the correct angle is. So I'm just going to say up here some question marks, and my angle, I'm going to just start off with 0. I'm going to default to this. And so now I can say my turtle dot left turn of angle. All right. So now I just have to figure out what the angle is, right? So here's the math I'm going to do for you. If you remember, a circle is 360 degrees. So we've got n sides. So my angle is 360 divided by n, the number of sides, right? Now, if you remember back on the very first stream, we talked about that if this is an integer and this is an integer, sometimes things can get off and I can lose the fraction, right? So if this is 7 and this is 360, it's not going to be an even integer, and I'll lose some stuff and it won't necessarily be correct. So what I'm going to do is I'm going to put a 0.0 after this to turn it into a float. So this will allow me to turn at fractions of an angle and avoid any error and loss of precision. So I'm going to compute the angle, and so each side takes 1 over n of a full circle, which is 360 degrees. Right? So we're going to move forward, turn a little bit, move forward, turn a little bit, and so on. So let's try this out. So I am going to draw Polygon with Bob, and let's make it an octagon where the side length is 100. All right, so let's hopefully this works. And there we go. We drew an octagon. So I can then switch it, and let's do, is that a dodecahedron? No, that's adhedron's going to be but there's a 12-sided one. Now, something interesting. Can't really draw a real circle in computers because of the way pixels work, but we can approximate it by basically creating a polygon with a lot of sides. So I can try, let's do 36. I'm going to make it a little smaller here. So I can make it a little bit larger so we can see it. So I can approximate a certain, whoops. No, that's not what I wanted. I can approximate a circle by drawing a polygon with enough little sides. Right? Anybody that's had calculus, this should be familiar. All right. So I can make a better approximation of a circle by having more sides. All right. So I'm going to leave that as an exercise for you. I'd like to see your solutions. You can post them in the Discord. So the challenge, your homework assignment, is to find out how I can write a function. So I'll give you the function here real quick. Draw circle, where you give it my turtle, and then the radius of the circle, right? And so don't know how to do this. So no, this problem is different, right? That it's, we're going to, here we're given the number of sides and the side length. But here I'm given a radius, right? How far this has to go, and you're going to have to figure out how to do it. It's pretty simple if you know the how to calculate the circumference of a circle. So I will tell you that. It's the equation to calculate the circumference, which is 2 pi r, will be necessary. So you will need circumference equals 2 times pi times r, which is the radius, right? And so you could have a function that draws a circle. So I will start off the stream next time with a solution that does it, just to show you. And there's a couple of ways. Now, if you think back to last week's stream, where we built functions, you could write it where you use this function. That would be fantastic, because then you don't have to rewrite everything, but you still have to calculate how many sides you're going to use and then what the side length is, right? So you've got to solve the problem. But if you want to do it where it uses this draw polygon function, that would be fantastic, because it shows that you're able to reuse stuff. If you don't want to, that's fine. I have a solution that doesn't reuse it, but it also changes colors as it goes through, because I have to over-engineer things and make it look cool, right? So I'm going to stop with chapter 4 here. Next, I'm happy to answer some questions. So if you can go ahead and send the mods some questions. So I'll wait here for a little bit to answer questions. We've had a lot of great questions tonight, so I'd be happy to answer some more. While I'm waiting for some of those to come in, I do want to tell you, so next week is chapter 5. So let me look real quick and just remind myself what chapter 5 is. So chapter 5 is conditionals and recursion. So basically like if statements. And then recursion is a function that calls itself. So it's, iteration and recursion go hand in hand. So it's a different way of solving the problem. It does break people's brains a little bit, but it's fun, and I like to stretch the brain. So, Just Ben asked a question: should we save pi for 3 weeks? The snarky answer is pi will go bad and it won't taste as good. So pi is, if you remember from previous weeks, pi is actually defined in the math package. So if you import math, it actually has pi for you, so you don't have to remember it or program it, and it has it in there. So I think we did talk about that in, I don't remember which week. I think it was when we started chapter 3. But it is in there in the math package. So if we go back to the documentation here, so Python API math, so it has in here all the mathematical functions you get when you import math, and there are also some constants. So there's pi, there's e, tau, infinity, not a number, which sounds really odd to no programmers why you would want to have not a number, but it's important. Like when you divide by 0, it prevents the universe from blowing up. But it's got pi saved in here, and so again, this is a good reference to have some of those things in here. All right. So Emmanuel asked a question: did I study computer science? Yes. So my undergraduate degree was in math and physics. But I found out that there weren't any jobs in that, and I liked the problem-solving aspect. So I went back to school and told my wife it was just going to be for a master's, and then when I finished my master's, I just kind of kept taking classes. So yes, I have a PhD in computer science. So my research specialty was the intersection of artificial intelligence, machine learning, bio-inspired robotics. So I had a number of National Science Foundation research grants on basically taking inspiration from groups of animals in nature and how to apply it to get teams of robots to work together. So it was pretty cool. So yes, I've taken far too many computer science courses. So yeah, so I do have a tendency, be careful, because I do have a tendency to dive off the deep end and get into theory. But I'm more of a practical, not a theoretician. So. All right. Well, I don't see any other questions, and at the risk of diving into too much geeky computer science stuff, I'll probably call it there. So, thank you so much for joining us this evening. Hopefully, I've dialed back a little bit on the math, and I haven't scared everyone away. So, I appreciate you watching. Please hop into Discord if you want to ask about your solution. Okay, I see there's a question coming in. I'll answer that before I end. But do hop into Discord and ask the question there. There's lots of people that will help. Remember, on the GitHub repository, there's a list of exercises. If you just want to do some homework, I have a list of problems that you can work through developing an algorithm and writing code. There's links to other resources, so more than happy to help you learn. One of the things I don't like about this format is I don't get to interact with the people learning as much, so I'm more than happy to help you when you jump into Discord. And one of the things I found is that there's a lot of other people that are willing and wanting to help. And unfortunately for me, they get there and they answer the question before I can get there. So feel free to jump in. So the question is, with what we've been taught so far, can we use this for the real world? I would say not yet. So like the next chapter, we're going to be talking about if statements. So conditional execution, that's really important. And then after that, we're going to be talking about some more about functions, iterations. We're going to get into strings, lists. And so we've kind of hit the basics. Now, you can write programs to do things, but at this point, it will basically be automating a series of steps, not really being able to adapt to input or different situations and things like that. So the idea is, and the course, when I taught it in undergraduate setting, was it covered the basics needed to get started. So once we're done with the 12-week series, we may go a little bit longer if it's popular and, we want to spend some time on some topics. So I'm happy to take it a week or two more. But it really goes through the first 12 chapters of the book. So once we get through that, you'll have a strong foundation then to build on and start doing stuff. So you could write programs to, do most basic things. You'll learn, have enough to be able to dive in and use some other utilities and libraries, because in Python, libraries are really where all the benefit is. So you'll have learned the basic ways of organizing code. Towards the end, we discuss some of the things about data structures. And data structures are basically ways to organize information depending on how you want to use it. So at this point, we've done single variables. We've talked a little bit about lists in the algorithm, but towards the end, so chapter 10 is lists, chapter 11 is something called a dictionary, and it's just like, a dictionary book you look up or a phone book. And then chapter 12 is something called tuples, which are kind of like lists, but different. And so we're going to talk about those different ways of organizing information. Once you've got that down, then you're able to do things where you can process lots of information. You can read in contents from a file, store them, manipulate the data, do things like that, stick it in a database, pull things out of a database, functions like that. And so at this point, you could probably use it for some basic stuff. But I would say once we're done with the first 12 chapters of the book, that's when you really got to have a strong foundation and are able to do some things. Okay, so I don't see any other questions, so I'm going to end the stream there. So thanks again for joining us. Make sure to follow me on Twitter. So every Monday I post the algorithm of the week. I post it there first. I think I do it on LinkedIn on Tuesdays before the stream to catch people who might not have caught it on Twitter, but follow me on Twitter for it. And I'm also posting some, since I'm a threat intelligence analyst, I post some interesting things I come across. And whenever I write an article on something, I've got an article coming out soon on collateral damage in cyber attacks. So with all the interesting things going on in Eastern Europe, that's something to pay attention to. But I'm happy to answer questions on Discord. Thanks again for joining me, and I'll see you next week.